Okay, so we went over these in class, so we're not going to do those right now. Let's go to the next section. Okay, so part one. So no calculator in these, so let's see what we can do. So we're going to try to solve these for x. So I think we would square both sides in this case. And we get 6x minus 8 equals x squared. Let's get all those on one side. So x squared, let's see, minus 6x plus 8. That's a quadratic. That's why we did that. So we're going to try to factor that. So I think 4 and 2 might work, and they both would have to be negative. So this loses our x equals 4 and x equals 2. And the good thing to do there is just to check them. Sometimes you get extraneous solutions. Let's just kind of see. So if I plug in 4 right there for x, 6 times 4 is 24 minus 8 is 16. Square root of 16 is 4, which works. So that one's a solution. 2, that would be 12 minus 8 is 4. Square root of 4 is 2. 2 equals 2. That's a solution. So check for extraneous roots by plugging in, basically. So subtract 7 from both sides. You get 2 times square root of x equals negative 4. Divide by 2. You get square root of x equals negative 2. Some people stop right here. But let's keep going and solve. So you get x equals 4. And let's just double check this works. So 2 times square root of 4. 2 times 2 is 4. 4 plus 7 is 11. 11 does not equal 3. That's extraneous. The reason some people stop is they see a square root as negative, and that's not really possible. So they just stop and say the solution is no solution. Identify any extraneous roots. So we're going to put both sides to the third power here. So we get x plus 5 equals 125. So x equals 120, which should work, I think. Cube root of 125 is 5. 5 equals 5. That works. This one, let's divide by 3 first. So we get x minus 2 to the 2/3 equals 4. We put both sides to the reciprocal power, so to the 3/2 power. So this is just x minus 2. That's so nice. This is the square root of 4, which is 2. So 2 to the 3rd, which is 8. So x equals 10. Let's just see if this works. 10 minus 2 is 8. Cube root of 8 is 2. 2 squared is 4. 3 times 4 is 12. That works. So we got it. Find the inverse of each function. So to find the inverse, you switch the x and y and solve for y. So it takes a couple steps. So y, or I guess if this was f of x, it would be the inverse of f of x, but I'm just going to write it this way, x minus 1 over 3. So that's the inverse function. Kind of makes sense, right? Instead of adding 1, we're subtracting 1. Instead of multiplying by 3, we're dividing by 3. Multiply both sides by 2. So you get y equals 2 times x minus 3. I'd be fine to leave it in that form. You're multiplying 2 instead of dividing. You're subtracting 3 instead of adding 3. It's the inverse function. Okay, so this one is composed. So this is really the same thing as f of g of 0. So let's do the inside part first. What's g of 0? So let's say g of 0 is when I plug in 0 right there. 0 plus 4 is 4. Now plug that into the f function where there's an x. So 4 squared is 16. Same thing here. So f of g of negative a. Do g of negative a first. So g of negative a would be negative a plus 4. I'm going to write it this way, 4 minus a. You could have written negative a plus 4. Plug that in for x right there. So that's going to be, instead of x squared, it's going to be 4 minus a squared, which is 4 minus a times 4 minus a, which is 16 minus 8a plus a squared. And probably just for fun, we change the form of that because we like this form better. So we have to find the inverse for this one. So off to the side here, I'm gonna switch x and y. So x equals 5, y minus 5. So x plus 5 equals 5y. And divide by 5. So we get the inverse of x equals x plus 5 over 5. Okay, so let's do this. So the inverse of f of 5. Okay, so f of 5 we're doing first. F of 5 would be, plug a 5 in right there. 25 minus 5 is 20. Plugging that now into the x function, the inverse function over here. So this is going to be 20. So this is going to be 20 plus 5 over 5. We get 25 over 5, which is 5. It shouldn't be a surprise that we plugged in 5 and we got 5 as our output because we're composing a function with this inverse. We're just going to undo each other. Well, let's show the work here and see what happens in this one. So I think I know what the answer is going to be. Plugging in c, I think the answer is going to be c. Let's do it one step at a time here. So the inverse of c would be c plus 5 over 5. We're plugging that in to this guy. Right, so that'd be 5 times c plus 5 over 5 minus 5. That cancels. You get c plus 5 minus 5. You get c, and no surprise, we plugged in c, we got c. It's inverse composed with the function. Determine if it's one-to-one. So one-to-one function, sometimes you can think about the graph like this one. If you think about the graph of this one, I'm not sure exactly what it looks like, but it's definitely a parabola. And so to be one-to-one, it has to pass the horizontal line test and the vertical line test. That doesn't pass the horizontal, so there is no inverse. If I did try to solve for x there, that would be the way to do this. So there is no inverse, but I'm just going to show you algebraically what it might look like. So you'd have y plus 5 equals 1/2 x squared. Multiply by 2, so you get 2y plus 10 equals x squared. Take square root of both sides, and when you do that, you get plus or minus on one side. And so x equals plus or minus. Because I get plus or minus, I get two different functions. It's not one function. It's definitely not one-to-one. So both x and y have to be kind of one-to-one. So that's not going to work. Whenever you have plus or minus, it's not going to work if you do it algebraically. You could think about it graphically as well. Just roughly, I'm not sure exactly what this graph looks like. Probably something like that. I'm thinking this probably is going to pass both tests, but let's just see. If we solve for x, let's see what happens. So we get y minus 1 equals 4 times x plus 2 to the third. Divide by 4. What I care about is I get one function here when I do this. So I have y minus 1 over 4 equals x plus 2 to the third. I'm going to put both sides to the 1/3 power. Still not a plus or minus, so that's good. And last step, I'm going to subtract 2, so I get y minus 1 over 4 to the 1/3 power. I guess minus 2 equals x. So that's okay. That's one function, so this is yes, it is one-to-one. Is it one-to-one? This is no. I should say no, it is not one-to-one. So no inverse, but it's no one-to-one. All right, log form. So log form would be log base of something of a number equals some number here. So the base is always down low. That's going to be 7. The exponent's always on the other side, and the 49 would go here. And this one, same thing. So let's put in log form. So it'd be log base of something of a number equals some number. So the 10 is down low, the negative 2 is the exponent on the other side, and then the 1 over 100 would go here. Simplify each logarithm, so kind of remember the rules. So that's really, these have the same base, so we could just multiply. So 4 times 1/8 is 4/8, which is 1/2. And simplify, that actually can be simplified, right? We could write it this way, different ways of doing this. We could write it as log 2 of 2 to the negative 1. That's a really sneaky step we can do. We can move that over, so we can do negative 1 times log base 2 of 2. That you might remember, that's a property that's just 1, so the answer is just negative 1. There's different ways we could have done that, by the way. Same thing here. This should be in parentheses, by the way. So we can move that 3 out to the front. 3 times log base 5 of 5. 3 times 1 is 3. We have the answer. So I see this as 3 to the third there, if you do the prime factorization. So now we have 3 to the x plus 2 equals 3 to the 6x. 3 to the x plus 2 equals 3 to the 6x. And so what must be true? These exponents must be equal, just logical, right? So x plus 2 equals 6x. So we get 2 equals 5x. And so x equals 2/5. And this one, let's change it to log form. I'm going to write it this way, but I'll show you what a more sophisticated math student will write in a minute. So it'll be e here, the 2x goes on the other side always, and the 10 goes here. But no self-respecting mathematician would write log base e of 10. They would write it this way, natural log of 10 equals 2x, last step, divide by 2, because natural log is when the base is e. So with base is e, just change it to natural log. It just makes more sense. So that would be the answer. How to simplify radicals. So this would be square root of 16 is 4, and square root of x squared technically is absolute value of x. It's one of the properties we learned with even exponents. This one is odd exponent, so I don't worry about the absolute value. So I get negative 2 is the cube root of 8, and then x to the, I'm going to write that in exponential form, so that'd be 9 over 3. So it'd be negative 2 x to the third. If you don't know the cube root of 8, like do a prime factorization. So that's really 2 to the third. So when we say like the cube root of 8 is 2, the cube root of negative 8 would be negative 2. You can have negatives as odd roots. You want to multiply and divide radical. Okay, so multiply. So I guess we could just multiply. You could think of this. It might be easier to do prime factorization. That's really our friend here. So I'm going to do 2 times 3 for 6. The prime factorization of 16 is 2 to the 4th. 2 times, if you do a prime factor tree, 2 and 8, 2 and 4, 2 and 2. So you see have 2, 2, 2, 2, 2 to the 4th, 16 there. So that might help us because now we have, if we multiply this, we get cube root of 2 to the 5th times 3. So it just might help us thinking it through. So we need groups of 3 of anything to pull them out. So I do have a group of 3 here with 2 2's left over. So I'm going to split it up this way just to show you the steps here. So I have 2 cubed times 2 squared times 3. And so this is going to nicely simplify. The cube root of 2 to the third is just 2. So 2 times the cube root of 2 squared, or 4 times 3 is 12. 2 squared and the 3 are left over inside there. How to rationalize the denominator, multiply by the conjugate. So the conjugate of this would be 3 minus square root of 5. And I'm just going to leave that up there for a minute. And we're going to simplify down here. So this would be 9 minus 5, or 4. So we get 2 over 4. And one of the reasons I didn't multiply was I hoping it might cancel, and it does. So we get 3 minus square root of 5 all over 2. Now your exponent rules. So I need the same base, so I'm going to do the prime factorization of 4, which is 2 squared. So we get 2 to the 1/3 times 2 to the 2/3. And if you know your exponent rules, you're going to add those. Well, 2/3 plus 1/3 is 3/3, which is 1. So this is going to be 2 to the 1st, or 2. Very nice. Calc is allowed, so you can use your calculator here, graph the function. Hopefully you know this parent graph, instead of increasing, it goes through this point, has an asymptote at y equals 0. Be sure to put the equation. I'm not worried about each specific point here, but it has this kind of a look to it. It's a decaying graph, an exponential decay. It's one of our parent graphs that we memorized. This one, if you think about the parent graph, I'm going to do that one first. So the parent graph would look like this. I'm going to do a dotted line, so it has this kind of a look to it, right? And it has an asymptote at y equals 0. This is going to be reflection over the x-axis. So everything's going to fold down. So that point's going to fold down to there, and the graph is going to do this. It's going to go down really quickly. Put the asymptote there. So according to the vertex, if you know the formula A times x minus h squared plus k, we did a lot of this year, right and left, up and down. So this one's going to the left 1 and down 4. So what are the vertex? That would be -1, comma, -4, h and k. I have a vertex, directrix, and focus. Okay, so this one we might need to know the directrix there. So the vertex is going to be at -1, comma, -3. It's definitely opening up positive, so it's a y equals graph. So I'm thinking the focus is going to be inside, the direction is going to be out there. I need to find that distance c. If you remember the formula, a or c equals 1 over 4a. It's 1 over 4 times 2, or 1/8. Okay, so it's not going to be easy to do. So I go up 1/8, and I go down 1/8. So this would be y equals -3 and an 1/8. This point right there would be -1, comma, -2 and 7/8. Be the focus. And the focal diameter would be, like, the way it works is this is a distance of 2c in each direction. So it's a total distance of 4c, but 2c in each direction. So 2 times 1/8 is 2/8, which is 1/4. So I go 1/4 to the right and 1/4 to the left, both of them actually. And then you could draw a graph. That's enough. That's enough points. And if you wanted to show that 1/4, it's just so hard. It's so small there. It's hard to tell. That's the equation of the circle. Okay, so the formula you need to know, which hopefully you know. You definitely need it for your formula sheet. Would be x minus 2 squared plus y plus 5 squared equals 49. So we're just plugging in. That's your h, that's your k. Obviously, that's your r. Okay, so I like to sketch it. It just helps me kind of like think through like what kind of parabola it is. So there's a focus point there, which means there's a directrix here. There's a vertex here. So just roughly speaking, it opens kind of that way, right? And we know that the distance from here to here, the c value is -4. We know it's negative because it's opening in the negative direction here. So I need to find a. So a equals 1 over 4c. So 1 over 4 times -4. So -1/16. So x equals -1/16 y squared. So x equals parabola is opening left. So the formula for this one, it's a horizontal ellipse. So the formula would be x minus h squared over a squared, because it's horizontal. Y minus k squared over b squared equals 1. And h and k are those two values. It looks like the a value here is, let's see, from -1 to 4, so that's 5. The b value goes from 2 to 0, so that's 2, so that's b. So now I can plug in everything. So x plus 1 squared over a squared, which is 25, plus y minus 2 squared over 2 squared, which is 4, equals 1. Graph this hyperbola, so we're going to start with the hk, which is 1, 0. So right here is our center. Underneath x is horizontal movement, so I'm going to go 3 to the right, make a point, 3 to the left and make a point. Underneath y is vertical movement, so I'm going to go 4 up and 4 down. The hyperbola, so I'm going to make my dot box. The asymptotes. And it's horizontal, which means it's coming off, these are the vertex points horizontally. So it's going to go look kind of like that. Y varies directly as x, so y equals kx is our equation. Let's plug in these. So y equals 6, x equals 4, divided by 4. So k equals 3/2. So my equation, we're going to plug that back in. So we get y equals 3/2 times x. That's my function. And then find y when x equals 12. So that'd be y equals 3/2 times 12, which is 6 times 3 is 18. Form an inverse variation. So inverse variation would be y equals k divided by x. I'm going to plug in these guys. So this would be 6 equals k divided by 4. So 24 equals k. Plug that back in. So you get y equals 24 divided by x. Now I'm going to plug in this guy. So you get I get 3 equals 24 divided by x. So you get 3x equals 24. You get x equals 8. Gets the graph, so the first thing I'm thinking, let's try to factor that guy. I see some factoring to be done. Hopefully maybe even something cancels. So x times x squared minus 4. Oh, something else cancels. So that cancels. That's nice. It's going to cause a hole at 0 comma something. And this is going to be 4 over x minus 2 times x plus 2. If you keep factoring there. So it has a couple of asymptotes here. So we got, let's see, x equals -2, x equals 2. I've got a hole at 0. It's going to come into play in a minute. Let's find the intercepts here. So to find the y-intercept, plug in x equals 0. You would get 0 over 0, which is undefined, so there is no y-intercept. To find the x-intercept, you plug 0 in for y. The denominator goes away, so you have 0 equals 4x. So divide by 4, you get x equals 0. But that's only if, I'm sorry, I really should do it after I cancel out that x. If you do that, you get, okay, let's do that. Let's plug in after. So if we plug in 0 equals 4 over x minus 2 times x plus 2, and that goes away, so you get 0 not equal to 4. So there is no x or y intercept. It doesn't cross the x or y axis here, so, well, that's interesting. Okay, we're going to have to plug in some points here, so let's plug in 3 and see what happens. So you're plugging into this guy, really. So if you plug in 3, that would be if x equals 3, then the y value would equal 4 over 1 times 5, or 4/5. The thing I care about, I'm not so worried about the actual value of 4/5, but it's somewhere up here. It's positive. So I know in this quadrant, it's kind of doing this. I'm going to plug in -3. And I really just want to see if that y is positive or negative. So y equals 4 over -3 would be -5 times -3 is -1, which is positive 4/5. So again, it's kind of up here somewhere. So I've got my left-hand side. I really need to plug in a few more x values. This is an unusually tough kind of graph here. So I'm going to plug in 1. The y value would be 4 over 1 minus 2 is -1 times 1 plus 2 is 3. So -4/3. So when I plug in 1, it's like -4/3. I don't know, somewhere around there. And then let's plug in -1. And we get y equals 4 over -3 times 1, or -4/3. So somewhere right around there-ish. Okay, if you plug in 0 after we cancel, we can find the whole here. So if we do that, we get 4 over -2 times +2, which is 4 over -4, which is -1. So I get -1. So 0, -1 is the whole. There's a hole right there. There's an open circle. So the graph looks to be doing something like this. I think that's right. We could double check it. Oops. Okay, so let's just see how we did on this one. So we're going to do 4x in the numerator over x to the third minus 4x. Oh, it's a beautiful graph. It's hard to see the hole. You might go, well, I don't see the hole. If you do a trace menu 5-1, you can see that it's undefined when x is 0 right there, right? There's a little tiny hole, a pinprick in the graph right there. There's also, when x is 2, it's asymptote. When x is -2, it's asymptote. Those are undefined values on the graph as well. So we definitely graphed that correctly. So it's really good. It's a tough one. Simplify the rational expression. So let's factor if we can, because I'm really hoping this factors. So it'd be 3c times 2c plus 3 over 3c. Well, the 3c cancels. You just get 2c plus 3. It's nice. This one, try to factor that. So you could guess and check it. 2x and x, 3. I think this might be 3 and this one might be 1, I'm guessing. And this is plus and this is plus. That adds up to 1x and 6x. That does work. So it does factor 2x plus 1 times x plus 3 all over x minus 4. And then times x plus 4, x minus 4. That's an easy one. And this one, not too bad here. So x plus 5, x plus 3. That cancels. That cancels. That's pretty good. So we get 2x plus 1 times x plus 4 all over x plus 5. getting there. Again, let's try to factor this first. So I think that's going to be a key here. So if we get x plus 1, x minus 1, then we might be able to get a common denominator. 2 over x times x plus 3. Whew. Don't have anything in common with those things there. So this one's going to be missing both the x plus 1 and the x minus 1. So I'm going to have to distribute up there in a minute. This one is lacking both the x and the x plus 3. There's really nothing in common. So up in the numerator here we have x squared plus 3x minus, in the numerator over here, if you FOIL those together, these two, you'd get x squared minus 1. So then we're FOILing or distributing that with the 2, so you get 2x squared minus 2, I guess, here. All of this is over all four of those, all those things together. I'm just saving time and not writing it. Okay, so then this distributes to both terms. So the numerator, I get x squared minus 2x squared is negative x squared. That's minus negative 2, which is plus 2. So I get plus 3x plus 2 all over x times x plus 3 times x plus 1 times x minus 1. And now I'm actually thinking maybe this actually factors. So I'm going to pull out a negative here. So x squared minus 3x minus 2. Whew. Pick some hard problems for this, huh? So we get negative times, this is going to factor, I think. Let's try anyway. So it'd have to be 2 and 1. And does it factor? I don't think it does it? Okay, so we're done. We've got it. Choose a letter and then 3 single-digit numbers. How many different passwords? So you want a letter. This one's a letter. And then 3 single-digit numbers. So these are digits. So the letter would be 26 different ones. There's 10 different single-digit numbers. So you just multiply those in your calculator, and you get 26000, 26,000. It doesn't say anything about repeats, so I just assume they're allowed. Is order important? Committee, when you choose a committee, I would say no. So right away, you're using NCR. So this would be 12, choose 3. Just type that in your calculator. If you remember how to get there, a scratch pad or something, then you probability 5, combinations number 3. So NCR 12, 3, and we get 220. He was recognizing, order is not important when you're choosing committee. Make a box plot. So this is more recent stuff. You probably know how to do this. You could consider using, letting the calculator do it for you. So I'm just going to call it list 12, 11, 18, 26, 14, 20, 24, 30. So we're going to calculator page, not a scratch pad, by the way. So menu 6.1, variable stats, choose list. It should do everything for us. So it looks like the minimum is 11 and the max is 30. So I need a scale that goes from, oops, bring that back up, 10 to 30. So 10, 15, 20, 25, 30. That looks good. And so the minimum is, the max is 30. The minimum is 11. Q1 is 13. Median is 19. Q3 is 25. So I'm going to draw my box. Whiskers, neither one of those look like outliers. I think we're good. How many standard deviations? Is this a different set of numbers? It is. So let's go back. Control left arrow. List 2, 12, 17, 15, 13, 9, 10, 12, 10, 15, 17. Okay, let's go back to calculate page. Then use 6-1. How many standard deviations? So we have a mean of 13. So like one way is just to draw it like this, like we like doing this. So the mean is because 13, exactly 13, that's nice. Standard deviation is 2.8. I'm just going to round it to 2.8. So standard deviation is 2.8. So I'm going to add 2.8 to get 15.8. Keep going, a couple more standard deviations in each direction. Sometimes on the calculator, what I'll do, whoops. Sometimes on the calculator, I will let it do the work for me. So 13 plus 2.8, so 18.6, then 21.4. And then in the other direction, 13 minus 2.8, so 10.2, 7.4, 4.6. I'd be surprised if any of these values are more than 3 standard deviations, so you stop at 3. So the biggest number looks to be 17, which is inside of 2 standard deviations. Smallest number looks to be 9, which is inside of 2 standard deviations, actually. So everything is within 2 standard deviations. So everything's kind of in that 2 standard deviations. 9, seen it right about there. 17 right about there. So everything's within 2. How many different ways can they finish? So not just the top 3, but all 5 of them, right? So this would be 5 ways the first person, then 4 ways left over, then times 2 times 1. That's 5 factorial. Or 6 times 4, 24 times 5. 120. Choose 3 scoops. How many different combinations? So order is not important. So I would say 31, choose 3. Choose different flavors. So you're going to choose 3 of those. So it's going to be another NCR because order is not important for this one. So NCR 31, 3, 4495. Don't forget to review some ACT stats. That is the review.